Hey guys, welcome back to RoboSiddhi and welcome back to ESP32 course. So, in previous videos, if you have seen, we have talked about ESP32 versus Arduino, right? So, if you have already worked upon any kind of microcontroller before, such as Arduino or any kind of other microcontroller, you might have seen that every microcontroller has pins. And by using those pins, you can connect multiple sensors to your project, you can connect multiple LEDs, you can use multiple motors, and you can make interesting projects. But we need pins, right? So in this video, we are going to talk about overview of the ESP32 board, and we are going to talk about how the pins are there in our ESP32 board, and we are going to compare it a little bit with our Arduino. So in previous videos, we have done Arduino as well, and if you are studying ESP32, there are chances that you have already studied about Arduino. It's okay if you have never done that, but let me show you a little bit how Arduino and ESP32 looks like. So this is our ESP32 board, and it's a really nice and black color, and you can see there's metallic needles are called pins. So we use them to connect our sensors, any kind of motors or any kind of LEDs. While as on other hand, this is our Arduino, and this is how it looks like. If you look closely on Arduino, there are two separate sections of analog and digital pins. So both are different and both are having different pin configuration and different pins and be different places as well. As you can see, these are the analog pins. They are on this side. Now they can't perform any kind of digital operation, while as the digital pins are there and they can't do any kind of analog operation. So that's the case in our Arduino. But if you take a look at our ESP32, this is our ESP32. There are no thing as analog or digital pin. There are GPIO pins, general purpose input and output. So how GPIO pins are there, how we use them, how it makes it a little bit special other than our Arduino. So in this video, we are going to find out and we are going to study about that. So let's go, let's compare it and let's have fun. Let's see how it works. Let's go. So as you can see, I have two boards, and one of them is Arduino, as you can see, and one of them is ESP32. Don't worry, this is not a comparison video. I'm just trying to show you how it differs from other microcontrollers. But if you look at analog pins of Arduino, we have analog section, separately analog section, and there you can see there's a digital section. So both pins are different and both pins have their each individual work. So they can't perform each other's work. Analog can't do any kind of digital work, while digital can't do any kind of analog work. That's the problem in our Arduino. Now look at our ESP32. Instead of having an analog and digital pin, this contains many GPIO pins. You can see there are so many GPIO pins. So they are called GPIO pins, means general purpose input and output. The same pin can be used as input or either output. Also, it can be used either as analog or digital. So that's the specialty of our ESP32 boards. Why we need such kind of feature, you may ask? Now let's head to our Arduino again. Now imagine I need 15 digital pins. So as we know, the digital pins are there in Arduino, and instead of 13 pins, there are 14 pins, I think, 0 to 13. So there are total 14 digital pins, but I don't need 14. I need 15 or 16 digital pins. What will happen in that case is I have to plug till 14, then I will run out of pins, right? Then there are analog pins, but I need digital pins. I can't use analog pins. Okay, understand it. There are 14 digital pins in our Arduino, but I want to use 16 or 17 pins. I need 2 or 3 pins extra. In that case, what can I do? I won't do anything because the board only has 14 pins. I can't do anything. I can't connect them. So what we can do is we can use analog pins. No, we can't use them because we need digital pins. So that's the biggest problem and bottleneck for our Arduino board. But whereas you see this is having GPIO pins, which means each pin can perform any operation, input, output, analog or digital. And also there are PWM pins as well. So that's how the GPIO pins are there, and that's why it's very special and it's such a powerful microcontroller. Now if you see, this is how it board looks like, and the board is going to have a USB port to upload or flash any kind of programs in your board. Then you are going to have two buttons. In Arduino, we only had one button, this one, that will only reset the board and it will restart the program. But in our ESP32, there are two separate button or switches. First of all, one is called RST, or it stands for reset. So this is for resetting the board, which means if you press this button, the ESP32 will restart, reboot, and it will delete each and every data that it have collected, and it will restart the loop again. So that's how it resets. Then we have boot button. So this one is called boot button, and whenever you are going to program the ESP32, you have to keep it pressed while the board is uploading programs. So that's when we have to use it. So I will also show you whenever we are going to upload any kind of programs, we have to press this boot button. After that, you can see there is a metallic a box here. This is the main microcontroller of our board. So this is our main microcontroller. There you can see there are some other components as well. There is a voltage regulator, then there is a flash chip, then we have some diodes and other essential equipment. Then we have a LED here. So this LED will stay on whenever you are going to power this up, or you can program it as well. Then it's all black on the back side, so you can also use it to solder it directly on your projects or your PCB. That's why it is having completely empty on outside. It's very clean and it's very smooth. That's why you can solder it directly on your project PCB. So that's how the ESP32 is there. One more thing, this is the antenna of our ESP32. So whenever you are going to make projects and whenever you are going to use a metal casing or a metal shielding, you have to keep in mind that you keep it open so it can communicate, it can send EM signals, electromagnetic signals outside the box. So that's how the ESP32 is there, and this is our ESP32 board. Now let's take a look at our our GPIO pins, and let's understand how they work more closely. So I have made slides for that. So let's go and let's see how it works. Okay guys, so ESP32 pin configuration. So we are going to take a look at the pins of our ESP32. Now let's begin. First of all, let's take a look at the pin out of ESP32 at a glance. What makes ESP32 pins special? So it's a special microcontroller, therefore the pins are special as well. Now let's talk about why it's so special. Okay, what makes ESP32 pins so special? Unlike Arduino Uno, like we have talked about, the ESP32 does not separate analog or digital pins. So the analog and digital pins are separate in our Arduino, but in ESP32 the both pins are combined. ESP32 have no analog or digital pins. They both are combined in one single pin, that is called GPIO, general purpose input and output. So that is known as general purpose input output. So that's how it works. It's the general purpose input output pins. Okay, so that's what we are calling GPIO. Then they are multifunctional, which means each pin can serve different roles depending on how you configure it in software, which means one pin can be analog, it can be also digital, right? So that's how it works. Okay, so that's how it's special. Now let's talk about what are GPIO pins. So you have heard of analog pins, digital pins, and first of all, if you don't know about both of them, it's okay. So pins are basically some electrical wire to connect something. So this is a wire to connect any kind of LED, buzzer, motor or sensor to your microcontroller or ESP. So that's what a pin is, right? GPIO stands for general purpose input output, like we have talked about. Programmable pins, right? So now we know that it's a GPIO. It can be an analog, it can be a digital, it can be an input or either output. But how we are going to use them, how we can make it digital, how we can make it analog, how we are going to modify it. So that's how the programming is helpful for us. So these are programmable. Like if I wanted to act as analog, I have to program it. If I want it to be analog, I have to program it. So through programming, I can define, I can instruct it whether you should be a analog pin or a digital pin, right? So programmable pins that read signals from the word or drive external component. Okay, which means it can read signals from a word. Like if you have connected a sensor, so it will read data from sensors. Okay, let's say you are measuring a distance, so the distance will be measured by the sensor and the data will be sent to our ESP32, right? That's how it's measuring the real world's entities or data. Then it can drive external component. What do you mean by that? It can drive external components such as motors, such as LEDs, right? Or servo motor. So it can drive external components. It can give power to external components. That's what driving external components is called. Then input devices. We can connect so many input devices just like push buttons, right? Then switches. There are switches in your home. Just like that, we have push buttons and switches. So if you have seen, let's talk about these buttons. So these are tactile buttons, right? Same are available on this ESP32 board. So they are push buttons or tactile buttons. Then we can connect sensors as well. We can measure temperature. Temp measure temp stand for temperature. Then light. We can measure light. We can detect motion. So that's how the input components are there. Input devices are there. Then we have output devices such as motor controllers, right? This is a motor controller. This is used to control a motor. LEDs, buzzers, relay or motors. So that's what we have written here. Output devices are such as motors, LEDs that are going to show us some output, some movement, some give us some light, right? Those are basically called output devices. All right. So the simple explanation of input devices are the devices that are going to convert real physical or mechanical or any kind of physical entity into electrical signals, while as output devices are going to convert electrical entity into physical or any kind of real world entity. Like for an example, an LED is going to convert electrical signal into light, but wireless sensor, distance measuring sensor is going to convert that kind of distance into electricity. That's how you can think of it. Then simple example, we can make a program that is going to help us read a button that is connected on GPIO 4, I'm sorry. Then we can also make a program to turn on an LED or off an LED at GPIO 2. Okay, that's what we are going to do in our first code. So stay tuned for that. And if you want any kind of components or like this, you can simply purchase it from our RoboSiddhi.shop. So we are also selling the components, very high quality components. Okay, now let's talk about our next slide. So there are safe GPIO pins. Okay, now let's talk about safe GPIO pins. It's going to be a little bit complicated, but if you pay your attention closely, I will explain it to you. What do you mean by safe GPIO pins? So there are many GPIO pins. So safe basically means it won't affect our program. Okay, what do you mean by that? It won't affect our program. So let's imagine a scenario where you are just making a project using ESP32 and your ESP32 suddenly restarts, reboot. You might wonder why that happened. It will be probably because you have used some of the unsafe GPIO pins. Okay, what do you mean by that? There are some pins that are connected to the boot function of our ESP32, that are connected to the boot function, okay, that are connected to our boot function of ESP32. Now what is boot? So whenever you have unlocked your phone or switched on your phone or your computer, like you just power it on, that is called booting. Okay, that's how you boot it. If you reboot it, you just turn it on, turn it off again and turn it on. So that's called reboot. So you have a basic idea of what is a boot. Boot is basically starting some electrical equipment or any kind of computer. So in ESP32 it's also a computer sort of. So that's what boot is. So whenever you are going to use those pins, you have to remember that if you use them, your ESP32 can crash the program and reboot again. So that's really be careful with that. These pins are recommended for beginners. Okay, so safe pins are recommended for beginners because they don't interfere with startup. Whenever the startup sequence is there, the ESP32 checks a lot of different aspect or connections, right? So whenever you're going to start it, there are some pins that you must not use. Okay, aren't tied to flash memory. So there are pins which are unsafe pins. These are connected to our flash memory. So whenever those unsafe pins gets any kind of signal, the flash memory can reset, right? So that's what we don't want. Okay, so you have to use safe GPIO pins. aren't tied. The safe pins are not tied to flash memory and work reliably with most modules. Okay, so what do you first of all, let's talk about flash memory. Flash memory is nothing but it's just like a ROM or a memory in which the microcontroller is going to store the program. Okay, microcontroller or ESP32 is going to store a program. Just like your PC might have SSD, RAM, ROM, right? Just like that, we have flash memory. Now let's talk about these are the pins that are safe pins. GPIO 245 are for LEDs and sensors and general input output, while as GPIO 18, 19 and 21 are for SPI and I2C communication. So if you are confused of what are the I2C communication, what is SPI, don't worry. SPI and I2C are communication protocols. Okay, so just like USB you have in your home, USB pen drive, or you might have seen Ethernet also. They are called communication protocol, right? So just like that, we have communication protocols in ESP32 embedded system or IoT. So SPI stand for serial peripheral interface, while as I2C is for IC to IC communication, just like that. Okay, and then we have GPIO 22, 23 and 25. These are for displays and relays. Okay, these are for connecting displays and relays. We are going to see displays also. Then we have GPIO 26, 27, 32. These are for ADC inputs. So what are the ADC? There are basically two values in real world, analog and digital. So ADC is basically converting these analog values to digital form, and we are going to see that in upcoming videos. Don't worry about that. Then we have PWM outputs. Okay, so PWM is also very important. Then we have safe digital and analog views. Okay, so these are called GPIO 33. Okay, so these are safe GPIO pins. So whenever you are a beginner and you are going to start ESP32, you must remember that you are going to use safe pins. Alright, now let's talk about different slide. There are special purpose pins. What do you mean by special purpose? So they are basically pins that are going to be helpful for some special kind of purpose. First of all, we have to boot. We have to start our ESP32. For that, we have boot pins, which are 0 to 12 and 15. So they are controlling the boot mode. And incorrect configuration can prevent startup. Okay, so whenever you are going to use that, you have to keep in mind that you don't use pin number 0, 2 or 12 or 15. So they are going to be messing up with the startup sequence. So you have to be careful. So you should avoid using them. But if you are good at programming, and after that course you are going to be, so then you will have to use them. Okay, then let's talk about UART pins. So UART pins are basically universal asynchronous receiver and transmitter. Okay, that's what UART stands for. Okay, just like USB Ethernet, like we have seen in a previous slide, I2C and SPI pins. UART pins are basically just same protocol as them. Okay, UART stands for universal asynchronous receiver and transmitter. Now the thing is, whenever you are going to send programs through your PC using some pin or USB cable, what will happen is you are going to send it to our ESP32. Then the protocol it uses is also UART. So whenever you are going to do that, the PC can mess up with our ESP32 startup sequence as well. Okay, so that's going to be a little bit messy. That's why you don't have to use that as well. Then we have flash memory pins. Okay, these are used for flash chips. Okay, so they are internally connected to flash chips, so do not use them also. Okay, GPIO 6 or 11, 6 to 11. Okay, so don't use them as well. Now we have ADC pins, analog input pins. Okay, so they are for converting analog signals. They convert analog signals to digital signals. If you don't know about analog and digital, just think of it as if I ask you a question, did you drink? Okay, did you drink water? Okay, so if I ask you a question, did you drink water? If you are a digital person, you are going to answer me with yes or no. Okay, if you are a digital person, you are going to give me answer in form of yes or no, nothing more than that, nothing less than that. Yes, either no. So that is called a digital value. Okay, so in computer world we have digital as well. So that is working on 1 or 0. If no, it stands for 0. If yes, it stands for 1. There is nothing more than that. But if you are an analog person, if you are using analog, then what will happen is I will say I drank a little bit. Okay, I will drink 0%. Either I drank some 20%, I drank 30%, like in form of some levels. Okay, so it's not yes or no, but something in between, and there is a lot of levels for that. So that is called analog values. All right, we are going to see them in upcoming videos as well. So the ESP32 has 12-bit ADC for reading analog values, sensor values. ADC 1 pins are generally more reliable than ADC 2. Okay, which conflicts with Wi-Fi. Okay, so ADC 1 pins are more reliable. Okay, ADC pins are more reliable. ADC 1 pins are. So ADC basically converts digital values, analog values to digital. Okay, you have to keep that in your mind. Okay, then ADC 1 is more safer than ADC 2. Then we have GPIO 25 to 27, which are ADC plus DAC. What is DAC? That is just invert of our ADC. ADC convert analog values into digital, while DAC convert digital values into analog. So that's just opposite of what ADC is doing. Then GPIO 32 to 39 are ADC 1. Then GPIO 2 to 4 are ADC 2. Okay, they are also safe GPIO. Then GPIO 12 to 15 are ADC 2 as well. Okay, so they are a little bit unsafe, so they are unsafe. Don't use them, or if you use them, be careful and use them with caution. Now we have PWM, pulse width modulation. Okay, PWM rapidly switches between high and low to simulate variable voltage controlling brightness, speed and position. What do you mean by that? Okay, let's say I have a fan and I have a fan in ceiling. I want to control the speed of our fan, ceiling fan. What I will do? I will just rotate the knob. Okay, I will just rotate the knob and it will basically control the speed of our fan. But instead, just imagine I don't have any kind of regulator or controller for fan. What will happen? I will be only either turning it on or turning it off. So let's study about it more because it's interesting topic. Just like a fan controller, you can control speed. Okay, but if you have only a switch, while as a switch can only on or off. So there's the difference between PWM and our typical digital output. While as PWM is like a fan controller that can control speed, that can also control brightness of our LED, that can control speed of our motors, and there are so many things that uses PWM. Okay, so it can be used to control LED brightness. Okay, then it can fade LED, like you can dim the LED, then you can control it by 0 to 100%. Okay, 100% means full brightness, 50% means half brightness. Just like that, you can control the LED brightness. Then we can also control the motor speed using this. Then we can control servo motor as well. So servo motor is a precision motor that can perform precision angles. Right? Then most GPIO pins support PWMs via LEDC peripheral in Arduino code or ESP IDF. Arduino ID, we are going to see that in upcoming video. And ESP IDF is just like Arduino ID. So they are both IDE. Now, we use LEDC to control the PWM. Okay, so that can control PWM. Instead of using analog, we use PWM here. Okay, then let's see another slide. So there are communication protocols as well. So the pins are using communication protocols also. I2C, that is heavily needed for OLED, controlling OLED. Then we need SPI for RFID, SD card or high speed applications. Okay, so I2C is there for OLED sensors and LCD, while as SPI is there for RFID systems. RFID is a card, basically you have seen it in your credit card, debit card. Also you have if you have went to mall, you can also see that in various products that they keep it for security reasons. So that is called RFID. Then there's a SD card module, so that also uses SPI. Then we use UART for GPS module, GSM module, right? So that is TX, RX, transmitter receiver. We have already seen it. So there are 3 protocols on one chip, right? There are 3 protocols on one chip: I2C, SPI and UART. Alright, so that's same thing we have written here. So SDA is our for I2C communication, you basically need two pins. Okay, which is first one is SDA, which is on pin number 21. Then we need SCL4, which is connected on pin number 22. Then for SPI we need four wires. Okay, for serial peripheral interface we need four wires. MOSI, which is multiple output single input. MISO, which is for multiple input single output, right? Multiple input output. Okay, input output. Then we are having SCK, which is for clock, and this is for chip select. Clock, this is for clock. Okay, then that can drive RFID, SD card modules and high speed modules. Then we have UART. So UART is also a serial interface where we use TX and RX. Alright, now let's talk about another slide. So let's talk about the conclusion. Okay, ESP32 pins are multifunctional. Okay, they can be used as digital, analog or PWM. Also, it can be used for communication task as well, right? Then safe GPIO pins are there. If we are going to make any kind of program, we will try to use those pins G2, 4, 5, 18, 19, 21 and these pins, right? When we need ADC pins, we are going to use these are referred pins. Okay, from 32 to 39 are ADC pins. Then we are going to use PWM pins. So we have to use LEDC function. Then we have to use communication pins. We are going to use 21, 22 for I2C, 23, 19, 18 and 5 for SPI. Then for UART we are going to use 1 and 3. 1 to 3. Okay, so you have to avoid pin number 6 to pin number 11 because they are flash dim. They need extra care. Alright, so that's it for this video, and we are going to meet soon in upcoming video. We are going to set up the ESP32 environment in our PC. So stay tuned for that. Keep watching RoboSiddhi. Goodbye. So guys, that's it for this video, and I hope you understood the basic phenomena and the basic fundamentals of GPIO pins in our ESP32, and you have understood how we use them, why it's very important. And also consider subscribing YouTube channel of RoboSiddhi, and our sale is live. You can purchase all of this equipment. Also you can purchase the premium course of our ESP32 in Hindi and in English language as well. So see you next time. See you in another video. Goodbye. Have fun.